Okay, so today's class objective is to understand memory. So we're starting chapter 5, which is all about system memory, which you guys have obviously got a little bit of clue about it because number 1, we covered it briefly in chapter 1. Number 2, you guys have removed and installed memory at least 3 times at this point as a minimum. And so you understand the basics of what system memory is. And by the way, this is all note stuff, probably get rid of the test, that kind of all that good stuff. We have 2 kinds of memory in our computers. We have static and we have dynamic memory, okay? Static memory is just that. When you write to it, it stays there as long as there's power, it stays there. It still disappears if the power turns off, but it doesn't have to be refreshed. Dynamic memory needs to be refreshed every few milliseconds. Okay? It's continually being rewritten over and over and over, and the memory controller on the motherboard is what refreshes that. Yes?
Hi, this is Mr. Runyon. I've got a Java update going on my computer. Is there any way to, it's just taking forever. Is there any way to stop that?
No.
No? Okay.
Just be patient.
Okay.
If it takes more than 5 more minutes, then you can turn it back on, but it'll screw up your Java.
Okay.
Okay?
Thanks.
Would you have restarted your computer forever? Okay, so dynamic memory gets refreshed all the time, it's rewritten all the time, and it's stored on what are called DIMMs and RAMs, okay? So of these 2 kinds of memory, we have them both in our computer. We have dynamic RAM, it's the kind that we have in sticks that we stick in our computer, okay? It is far cheaper than static RAM, which is why that's what is being used in our PCs, okay? So when we go and buy a stick of memory at online, or let me just force this in here. No, that's it. When we buy a stick of memory online, it's always dynamic RAM. It's slower than static, okay? But that's what we have in our computer. We do have static RAM. That's what the cache memory, that's the kind of memory that comes with our CPU, okay? That's way more expensive. It's faster than dynamic RAM. That's why it's limited how much is on that CPU, because it's more expensive RAM to make. Okay, so when we're talking system memory, those sticks, we're talking dynamic. When we're talking the kind of RAM that comes on our CPU, we're talking static. Okay, when the CPU writes to its cache memory, it doesn't have to keep rewriting it. It writes it once, and then it reads it when it needs it, rewrites it. It doesn't have to keep refreshing it, whereas the main memory keeps getting refreshed on our PC. Okay, we already know these things when we talked about the CPU, but I thought I'd go over it again. The difference between the L1, L2, and L3 caches are, again, those are all static kinds of memory that we have on our PC, and those are all determined by our CPU choice. Okay, when we did that in chapter 4, we know that the more cache memory we have in our PC, the less often it has to go out to the system RAM. And so that's our static RAM that we've got on our PC. Okay? So majority of what we're talking about in this chapter really is not static RAM. It's the RAM on the motherboard that we can easily replace and put in. It is the simplest and cheapest upgrade you can do on your PC. Okay? And if I use the term, hey, we need to upgrade the RAM on our computer, it means to buy more and put more in. Okay? That's what upgrading your RAM means. You can't actually, right? You can't do anything to this chip to make it better. I can just toss it aside and put in a better one in my computer. But that is by far the easiest and least expensive upgrade. One of the articles you guys are going to read in the process of this chapter is called How Much Memory Do I Need in My Computer? Because a lot of people don't know. Some people willy-nilly add lots of RAM to their computer that they don't need, and some people have far too little, and at the cost of RAM today, which is really, really low. RAM is the easiest way to make your computer run faster. Okay, so we've got those RAM sticks on the motherboard. We've gone through a whole evolution of RAM. This is the oldest kind of RAM, which used to be called SIMs. These are all gone. I have a bunch if you want to add one to your keychain just for fun. By the way, we like my Christmas number. So the older EDO RAM, this was ridiculously expensive for 4 meg. 99 bucks we used to pay for 4 meg stick of RAM. That's the price tags are still on that bag if I find it today. But we've had an evolution of RAM, and now we're down here with DDR. In the current RAM today is DDR2 and DDR3. Those are the current ones that any system you purchase today are going to use. Okay. So we turned into here. We became synchronous RAM, and we'll talk about what synchronous means. Became synchronous dynamic random access memory is what we turn to here, SDRAM. And then DDR stands for double data rate. Okay, we went from SDRAM to DDR because the first sticks of DDR, which were also SDRAM, were twice as fast as that was, so they called it double data rate. Okay, and then it got even faster, and we turned into double data rate 2 and double data rate 3, which is where system memory is today. And if I ask you what's the current kind of RAM today, the answers are DDR2 and DDR3. Both of those were prevalent today. Okay. What it looks like, this is a stick of SDRAM, and it had 2 notches. It has these little clips that are very defined, and that's what the locks go into on the motherboard to hold them in place. And then really the only difference as I look at RAM is the notches on the bottom. Current RAM today, DDR, has 1 notch, and its predecessor had 2 notches. So all DDR has 1 notch when you look at it, okay? And as we went from DDR to DDR2 to DDR3, the only thing that physically changed that you could look at and notice the difference is this notch moved over a little bit and it moved over a little bit. And that was so it couldn't physically fit in the wrong motherboard. Okay? So that you couldn't go and try to put DDR1 into a DDR2 computer or vice versa. Now I have had students put their full body weight on a PC before trying to make it fit because it's the same length. Okay? And if I hold up a stick of DDR2 and DDR3, if you're looking for that notch, you can certainly see the difference. Got both DDR2s here. Exactly the same length, okay? The only difference between the two is those notches. I have to hold them up right. You can see that it didn't move a lot. Can you see the difference between the 2 notches? Yes? Yes, you see the difference? It moved, but it didn't move a ton. And I've had more than one student that grabs the wrong stick of RAM, doesn't actually look at the motherboard to see if the notches line up, because you should every time you put in memory. And then they're sitting there with their full body weight trying to get that to snap in. Okay? If you put all your weight on a stick of memory on a motherboard, something's going to give. In general, it's probably the little notch in the motherboard and you just broke the motherboard. Okay? So make sure those notches match up. But I can't just look, I just can't go like this if I don't look at the sticker and say, this is definitely DDR2. So you can't either. Okay? So read the dang sticker so you can say, it says right there it's PC2. We'll talk about that, but that means it's DDR2. Okay? So, we already know from when we did our research on motherboards that there are form factor things that have to line up, right? So if your motherboard takes DDR2, you must buy DDR2. And on our slides that we did on our motherboard, one of the reasons you had to say the compatible memory is there isn't just one kind of DDR2. There's many different speeds of DDR2. There's many different speeds of DDR3. So 3 different speeds of DDR1, but you have to make sure it takes the one that you're putting into it, okay? So when we go and look at memory, we have to make sure we're getting the right one physically to match our form factor of our motherboard, which is what that notch is the form factor of our motherboard. And then we also have to make sure it matches the compatibility of our motherboard as well. These are just different sticks of DDR, okay? So those are things we have to look out for. So our RAM today is synchronous, which means it runs in sync with the system clock and whatever the motherboard is rated. And that's why when I said if you can't find the bus speed of your motherboard, look at the memory speed, because it's all synchronous, and since the motherboard synchronizes up with the memory, then those two numbers are generally the same, okay? So it's synchronous. It runs in conjunction with the motherboard. So if you put slower memory in the motherboard runs slower too. So if your motherboard says it takes DDR3, yay, it takes the fastest time, and it says 1800/1600/1333/800, I'm off the page, /800, that means it can take speeds of 1800 megahertz, 1600 megahertz, 1333 megahertz, or 800 megahertz. And you go online to shop and you say, well, I can save $5 if I buy the 800. You just slowed your motherboard down to less than half of its potential. I'm not saying you have to buy the 1800, but you'd be really silly to buy the 800. This is going to slow down your whole PC. It's not just the memory that's going to run slower, because it synchronizes with the motherboard. It's going to make the motherboard run slower too. Okay? So our memory has a large impact. That's why I said it's one of the cheapest and easiest things to impact and upgrade. If I go and look at my current motherboard, I see I've got DDR3 800, which is the slowest they made in there, and it takes 1333. How much faster did I just make it, right? I just made it, what, 30-some% faster? Dude, roundhouse math in my head, I don't remember, but you get the picture, okay? It's called DDR because it's double the data rate of the original SD-RAM that came out. Don't get hung up on that, because that was only true for one day when it came out, right? DDR, the fastest DDR RAM was 400 megahertz. Oh, I'm sorry. I'm saying it wrong. SD-RAM, the fastest SD-RAM was 133 megahertz, and when DDR, and we didn't call it DDR1 because it was the other one, it started out at 266, which is twice 133. So it was double data rate, but then DDR became 400 megahertz. Now the DDR, it's not double anymore, but that's where the name came from. Because when it originally came out, DDR was twice as fast as SD-RAM, and then DDR2 and DDR3 don't mean it's doubled again, okay? DDR came out and it went up to 400, DDR2 came out at 400, and it goes all the way out up to 800, and DDR3 came out at 800, and I don't even know what it's up to now. But the DDR stood for double data rate when it first came out. And then we have another kind of RAM that was called RAM bus. It died. No good computer uses it anymore. It's kind of dead kind of RAM. So that's the basics of RAM. We're going to talk about the speed things. There's also 4 servers. RAM that does error checking on itself. Okay? Error checking RAM is called ECC because it has error checking code RAM that you guys are going to buy should be non-ECC. For a normal system, normal PC, you're going to see that it either says non-ECC or ECC, one of those two. And your motherboard is what determines that again. It's part of the form factor. The motherboard has to take either ECC or non-ECC. Occasionally you get a really weird PC that takes both. We have some HP workstations that are really wacky. They take non-ECC of 1 gig sticks or less, and ECC sticks of up to 4 gig. It's really weird how what they take, okay? ECC does an error checking procedure that adds together the numbers every single time it reads and writes to make sure that things add up, okay? Every byte, let's say we got 2, 3, 4, 5, 6, 7, 8. That's a byte, right? 1 byte is 8 bits, okay? So let's say it's writing this number, okay? If it has even parity checking, it has one more spot here, and what it does is it adds all the ones up, and if the numbers are already even, it makes this a 0, and if the numbers are odd, it makes this a 1 to make the whole thing even. So that every time it writes, it double checks to make sure that the things make sense, and then when it reads it, it double checks it again. Error checking memory is slower because it does this every single time it reads and writes. Supposedly it doesn't mess up as much for a server, that's why they have it, okay? But you can't put ECC in a non-ECC machine and vice versa. This is part of your form factor of your motherboard. You have to make sure it's got the right kind of memory, okay? It also means it's more expensive because when it's got memory, these, okay, if I look at this physically, I have 8 memory modules right here for the 8 bits of data when you read and write to this. On an ECC stick, you'll see another one, usually it's right in the middle. It's a 9th. So it's more expensive because I have to have more memory on my memory in order to write ECC memory. Okay? I just want you to know what that term is, so when you see it, when you go to look at RAM, you get the right kind. I'm going over terms right now. You're going to see when you look at that. Okay? There's something called CAS latency and RAS latency when we go and look at memory. Okay? Think of memory like an Excel spreadsheet. If I here, you know what, if I did this right, I'm gonna do another one, and I'm gonna do this. I'm gonna say it's 2, 3, 4, 5, 6, 7, 8. Excellent. Okay. So here's my memory die. Okay? And every time it writes, it's writing its zeros and ones. Okay? And I've got rows and columns in my memory. Okay, so think of it like a big spreadsheet of spots that the computer's writing to. What the CAS latency and RAS latency is, refers to the speed that it can write to a column of data or a row of data. Okay? It's actually the wait time. Latency means wait, okay? It's the number of clock cycles it takes to read or write data. Okay? With it being the number of clock cycles to read and write, would it be faster if the CAS latency or the CL number would be faster if it was high or low? Low. Low is a good number. When we look at clock cycles to write data, that's how many times we're on the bus before the data is actually written, okay? Lower numbers are good. So if I look and I see a CAS latency of 2 on one stick of memory and a CAS latency of 5 on another stick of memory, that is the faster stick of memory, everything else being equal, okay? So that's what the CL rating or the RL, but normally they just list 1, they'll say CL2, CL9, whatever. That number is a way for you to compare memory. Lower is better, okay? So when I look at memory, this is how I look at the speed. Okay, the first thing I'm going to look at that is really the megahertz, and should say and the PC rating. When I look at memory like this one, I'll look at this stick of RAM right here. Since I got it in my hand, okay? It says it is PC2 6400 RAM, and it runs at 666 megahertz. This is all off the sticker that I'm reading. Okay. And let's see if it gives me the clock cycles. It does not. Okay. So first of all, when I look at a stick of RAM, I look at this. This is the generation of RAM that it is. If it's PC2, it means it's generation DDR2. If it says PC3, it means it's DDR3. If it just says PC, it means it's DDR. This number, higher is better, right? It's DDR3, it's newer than DDR2. So that's the first way to look at which one is better. The generation should be higher for it to be better. The second thing we look at is the speed in megahertz. How fast is the RAM? Okay, so I'm looking at this chart. I'm going to look at the PC rating, and in this case it's a 2, and the megahertz, in this case it's 666 megahertz. Not the fastest that DDR2 goes, but almost. There's only one stick that's faster. Okay? How much memory is installed does not affect the speed of the memory. It only affects the overall speed of the PC to a point. Okay? So I really don't like this even being on this slide because it has nothing to do with the speed of the memory. Okay? Memory technology being used, what it's talking about there is an ECC or non. ECC is the main thing we're going to look at. Which one's faster? Oh, I'm already down here. Ahead of myself. I'm going to say the technology being used, I should take that off that slide too because DDR3 and DDR2 all use the same technology. The clock rating, the CL rating, lower is better, okay? So if I go and I'm shopping for DDR2 666, they're all the same. The only thing I can look at then is the CL rating to see which one's faster. We're going to go look at a couple here in a second. Okay, and the last thing is, does it have error checking code? Non-ECC, non-parity, non-error checking code is faster. Okay, and that's what this chart right here is talking about. What do I look at to say if it's fast? Okay, and I will say that total RAM has nothing to do with how fast the RAM itself is. That's going to affect the speed of the PC. Kind of technology, we're all looking at DDR now, so that really is not a way to compare RAM because you're not going to look at any other ones. We don't get rated speeds anymore. All we get is this megahertz rating, the rated speed, what it's at, which is really related to the form factor of the motherboard, whether it's ECC or non-ECC, and then the clock rating. I'm going to go and show you some memory right now. We're going to go and look at some sticks of RAM. And we'll just go do it so you can see what I'm talking about. Hardware, memory. We'll look at memory for this 780 that's sitting over here. So we're going to go over here to desktop memory. And then as I go over here, the first thing you can see is the kind of memory, which kind of memory am I looking for, okay? And I don't even know it takes DDR4, that's brand new. It must have just come out. I'll have to look at that later. I'm going to check DDR3, and you can see DDR2 and DDR3 both have 240 pins because they look exactly the same. So I'm just looking at DDR3. I'm going to look at the exact same speed, so I'm going to show more. I'm going to go down here to 133. So I'm just looking at the exact same speed of RAM. I'm even going to be specific, say I want the same size. I'm going to look at 2 gig sticks. So I'm limiting myself now down to 8 different sticks. So as I look at these, I've picked all the same. So this is DDR3 1333, PC3 1066. Really, you're just looking at the PC3. Okay. This one also is DDR3 1533. Okay. So as I want to go and compare these, I'm going to open this one up and see if it even has all the information here. As I go to compare these, this one is giving me nothing. I'm not even looking at that one. I need to look at another one that has full specs on it. See if I can find another one. There we go. So as I look at this one, I can see the cast latency is 9. By the way, when it shows timing, that's overall timing. Cast latency is the first number. So this one's DDR3, this one's 1333 megahertz, this one's DDR3, 1333 megahertz, has the same cast latency. Let me see if I can find one that's different here. 999, 999. Can't find a single one that's different. So all things being equal, on these, they're exactly the same speed. I guarantee I'm going to find one on the test for you that has 2 different cast latencies, and I'm going to ask you which one's faster. Let's see if I can find one. If I change my size here. 9, 9, not specified, not specified, 9, 9, not specified, not specified. Man, let's get them here. I've got about 10 these things. There's only 2. 9 and 9. That's the same again. That is not always true, by the way. Okay, so here's one that has cast latency of 8. It's 2x4. I'm going to pick 2x4s and maybe I'll be able to redeem myself here. Okay, so this one is 2 gig sticks, has a cast latency of 9. This is 2 gig sticks, has a cast latency of 8. Everything else being the same, if this is DDR3 and it's the same speed as this DDR3, and it is, the only thing that's different here is this cast latency is 9 and this cast latency is 8. So which one is faster? The 8. Okay, and they're exactly the same cost. Okay, so if you're going to purchase one and you see this difference with the exact same cost, the exact same size, which appears to be the exact same speed, because they both say they're 1333, 1333, 2 gigs, 2 gigs. This one is faster down here. Okay, that one's a faster stick or set of sticks of RAM. That was way too hard to get to. Okay, so what we're going to do now, you guys are going to read this article, okay, online, and then you're going to answer those 5 questions. Okay, so you're going to go read this article, which covers much of what we did, but don't do it yet. I'm going to talk about the next few days. So you're going to read that, and you're going to answer these. This is a journal. We haven't used a journal in here yet. Basically, you just click edit, you copy the questions down into the journal, and then you type your answers in there. Okay, so I'll be able to read which question you answered right there in the journal. Okay, that's what that is. If you get done with that, which you may get done with that today, then you can go on to Memory Day 2 and Memory Day 3. Those are the 3 days worth of stuff, because I don't have, you're going to have all these done before I come back. Okay, but when I look at the, basically where we're going here, you guys are, switch review. I want to talk about the thing right now. You guys are going to do these readings on your own. This one has a quiz after you read these 2, and the quiz really covers this, this, and this. Okay, it's just to check how you're doing, whether you read that stuff. Memory Day 3 stuff, understanding RAM timing, which we kind of just talked a little bit about, and how much RAM do I need? This one's really just to let you see how much RAM the system really needs, and this is as basic an article as you can get. It's really just a chart saying how much RAM do different games need, because if a lot of people, and I know it's got Windows 7 stuff on here, Windows XP stuff on here, but when we look at Windows 7, minimum is 1 gig, recommended is 4 gig, okay? That's for Windows 7 to run really well, but sometimes there are recommendations for games that are much, much higher than that if you're a gamer, okay? So your system would run great maybe if you've got 764-bit with anywhere between 4 and 8, but you may find a game down here that says, oh, you really need to have 6, and I will tell you I haven't updated this for very current games this year, so there's even higher. So some of this reading is just so you know, but really it's all to get you into the memory PowerPoint project, which I want to talk about now before you guys get into that review, okay? So, you're continuing on with what you did on the CPU. Okay, this one is going to be really easy. That's why there's reading while I'm gone, because by the time you do that reading and you do this PowerPoint, we're really going to be done with the whole chapter when I get back. Okay, you're going to present, we're going to review, and then you're going to take the test, okay? So in this case, just like you did with CPUs, you're going to present 2 types of memory for one manufacturer, okay? So both your choices have to be from Crucial or Kingston or whatever. I'm not going to specify who you have to use, but once you choose the memory for one, you have to stick with that same manufacturer for the other one, okay? So I'm not going to assign manufacturers then. Okay, so you're going to be using your motherboards again, okay? You're gonna wait. Where is the? Maybe I did have it before. Oh, okay. Never mind. I take it back. So you have to make a choice on what you're gonna do, so everybody does something different. Okay. So as we look here, one of your of the 2 types, if you choose this one, you're going to find the fastest memory for your business motherboard, and the cheapest one you can for your gamer. This one is the fastest memory for your gamer, and the cheapest for your business. Okay. So you're both looking at speed and cost. So everybody's looking to get 2 different things: one's speed and one's cost. So you're going to use different motherboards, same manufacturer, and one on each of these. You're looking for cost, and the other one where you're looking for performance. Okay, so let me go back to the assignment. I know you guys all are looking to jump on. I don't think which one I have. So you're presenting 2. You're going to introduce your memory manufacturer. You're going to again tell us the board that you're talking about. You have to say, hey, this is for the Asus blah board, and show us one slide that shows the compatible and types of memory that it does. Okay, and then you're going to go into the memory and explain these things as you can find them. Just because they're not on Newegg doesn't mean they're not on Kingston or Crucial or whoever's website. If you go and choose some rinky-dinky kind of RAM that no one's ever heard of, you might have a harder time finding this information, okay? So you have to tell us access time, not all of them list that. Bandwidth, that's the speed, whether it's parity or non-parity, ECC or non-ECC. Does it do single, dual, tri, quad channel? You're going to read an article on that. What kind of latencies does it have? What kind of contacts? Contacts could be gold or they could be tin. Okay? Gold contacts are way better than tin contacts. Okay, so you're going to explain that all to us, and then obviously give us a price, link to the price, just like you did with the CPU. Okay? So that's where we're going to get to on your CPU project after you've done these other readings and assignments and and I will tell you there's going to be a quiz here on day 3. I just don't have that one opened up yet. Okay. So that's where you guys are what you're going to do during the 2 classes I'm not here next week. Okay. So today you're going to read and do this, and during the 2 classes, these are the 2 sets of readings that go along with the research you're doing. And I will tell you that this one you don't have to do in order to get it going. That's why you're going to do this, take the quiz, and start doing your research for your project. Okay. Questions? Okay, as always, you can email me while I'm gone. I'm going to stop my recording, start